chose our deadweight tester as a standard to use to calibrate this. Why? Because the accuracy of the deadweight tester is 0.1% of reading. So if I give it 50 psi, it's 0.1% of 50, or 100 psi, it's 0.1% of 50, not full scale like a pressure gauge. So this one is 0.5% of full scale. It's a 300 psi gauge, so that is plus or minus 1.5 psi. So here's what we're going to do. If you want to come in closer so you can take a look here. Here's the pressure gauge. It's got a serial number engraved on it. Phenolic case. Pretty solid little gauge. So we're going to pop the face off to start with. Give us access to it. I got a special tool I made up that fits right on those ridges so you can get some torque on it. Keep going on getting this face off. Nice and gentle. Nice and gently. Without messing anything up. Okay. Now let's load it in the deadweight tester here. Okay, so we're loading the deadweight tester here. We're going to pick points at 25%, 50%, 75, and 100% of scale and put our plates on there. Now the way this works is each plate is marked with a certain weight, such as that one. See, it says 5, so that's a 5 psi weight. 10, 40, 100, we're going to stack them up to the equal that. And you pressurize with hydraulic fluid until the mass pushing on this area of this piston equals that psi. So let's start. Our first point is 50. Let's take her up to 50. Building up the pressure here. Then you want to spin the weights to make sure there's no extra friction on that shaft, and you get the weights kind of floating right there. If you take a look, it's about 2 marks low, which is 4 psi, which is out of our tolerance. But we got to check all the other points first. So let's go to 50%. Got it floating and spinning. We're still 2 marks low. Let's keep going. We're at 250 psi, it's still 2 marks low. Same thing. Add another 50. At 300 psi, it's still 2 marks low. Okay, so we'll take it back down to 0. I remember this isn't there's things that we do before and after a calibration that I'm not showing you. I'm just showing you the meat and potatoes here. Let that drain to 0, and then we'll make our adjustment. Make sure we get all the pressure out. Okay. Now you can see the zeros on the lower end, so we have some adjustment. I'm going to adjust it up about 2 marks, then we'll test it again, and that should do it. I'm going to watch this part. This particular gauge has an adjustment screw right there on the needle. This is called a needle adjustment or zero adjustment. Okay, now you can see that zero's a little bit higher. Let's do the same procedure and hopefully that should take care of it. Alright, 50 psi. You see that's touching the 50 mark, which is pretty good. Let's take it to the next mark. Exactly 150. Take it up again. Take a look right there. That's 250. And then right there it's at 300. Okay, so this gauge is now within tolerance. What we'll do is we'll take it out, we'll make sure we get all the hydraulic fluid out, We have a paperwork that we fill out, of course, to make a certificate, new sticker, clean the gauge, do all of our QC checks, and then give it all this information and gauge back to the customer. Now with calibration, a lot of people say, why calibrate stuff? Well, here's a prime example. Let's say you're using this gauge to test pump pressure for a critical application in a factory or something, and 1 psi makes a difference. Well, this one was over 2 psi off, and who knows, or no, 4 psi off. So who knows what would happen in a couple more months? It might get a lot of vibration and get off even more and more. So that's how calibration can help different processes. So my name's Greg, and this is This Old Shop, and thanks for watching.